Alrighty, so we downloaded 3 samples for number 1 and 2. Let me zoom in, read it. Number 1 and 2, we are using sample 2. So upload sample 2 into Statcrunch, then answer questions 1 and 2. Alright, so I have a Statcrunch open right here. I'll go to data, it's okay, load, and click on or go to from file, and on my computer I'll drag sample number 2. That's the one with UK and USA, right? Okay, and then I'll go ahead and do upload. Okay, now what are we doing with this data set? I'll go back and read it. It says, conduct a 2-sample t-test of the null hypothesis that the mean height for all UK students in the census school database is equal to the mean height for all USA students versus the general alternative of some difference. So we don't know if one population is taller or shorter, is American children or students taller, or UK students, I don't know. So the alternative will just be that there is a difference. So if there's no difference, we're gonna just subtract their average and set it equal to 0. Or for the alternative, we're going to use a symbol not equal to, okay? And I give you steps. And this is what we're going to do. Let me go ahead and read this, and then we'll go to Statcrunch and do it together. Select stat t-stats, 2-sample with data. Sample 1 is height, where country equals UK. Sample 2 is height, where country equals USA. And it says you will need to click build and build this expression. How about I go ahead and, well, you know what? Hold on. Maybe I can have both screen open. And it says choose hypothesis test and fill in the appropriate values for the null difference in means and direction of test. Do not pull variance. We don't pull variance because I guess we're not assuming the population variances are equal here. Okay, so I'm going back over here. I'll go to stat, t-stat, 2-sample with data, okay? Variable 1 is height in UK, so I may have to use the build function. Look, this is the first time we're using this build function. I clicked on height, and under where, click on build, and use country equals UK, okay, and that's it. Go ahead and click OK. And for sample 2, do height again, but this time not the UK. Do build function, type in or click on country, do equal sign, and do USA, and that's it. I'll zoom out, click on OK, and let's do the null and alternative hypothesis. Null is that they're equal. Okay, so if you do mu1 minus mu2, they equal 0. The alternative is that they're not equal to 0, so this is perfect. I didn't have to change anything on their hypothesis. So I'll go ahead and click on compute, and I'll get this table, and we will start talking about this table. I copy this, and as you know, your numbers and my numbers are definitely going to be different because we use different samples. Dun, dun, dun. All right. So what should we look at? We should look at the p-value, right? So the sample difference was negative 1.8. I think the unit is in centimeters. So what we are saying is when we did the average height for UK minus average height for USA, the difference came out to be negative 1.8. So what does that tell us? When do you get a negative number when you subtract? When you do small number minus big number, right? So in my sample, UK was smaller number, USA was a bigger number. What does that mean? I had taller USA students in my sample. But is that difference significant enough? Well, look at my p-value though. My p-value came out to be 0.4788. 0.4788. So what does that mean? That's a big p-value, right? So I'll go down here and do my interpretation. Is there statistically significant evidence for a difference in mean height? There is not. I'm going to go ahead and go with this word. There is not. There isn't statistically significant evidence for a difference in the mean height between the UK and USA since the p-value of, what was the number? I forgot. 0.4788 is greater than the significance level. And what were we comparing to? It doesn't really matter. It's so big. It's bigger than 10%. I guess the significance level was 0.05. So I can say a significance level of 0.05, and this is perfect. This is perfect. So we did number one, we just did number one. Maybe we can do number two too. Very similar. All right, let me zoom out a little bit. But what I'm thinking is I may be able to put the interpretation and the table on the same page. I'm gonna do that. Oh, that looks good. Okay. All right. Why not? Let's go ahead and do number two on the same video. It says construct. Ooh, we're doing a confidence interval. So, guys, look. My results said they're not really that different. That's what it says. Okay, heights are. This could just be from sampling error, right? Could be just sample variation. This difference. So what I'm expecting is when I do my confidence interval, I will probably get what number in my confidence interval. It's going to include 0 in it because there's no significance difference. So let me see. I will go over here and read number 2. Construct a 95% confidence interval for the difference in mean height for all UK students in the census school database and the mean height for all USA students. Repeat the steps for question 1 except choose confidence interval and fill in the appropriate value for confidence level. I'll show you something. So you go to your Statcrunch that you are working on. Instead of going back to stat, tstat and all, you can click on option. Click on option. Click on edit. So that I don't have to redo all these where and the build function. I'm just going to go over here and click on confidence interval for mu1 minus mu2. The level is 0.95. I think that's what we wanted. And that's all. Compute it. And let's highlight this. I'm sorry, not highlight. Take a picture of this. And I'll put it over here. I will talk about this. Now look at the confidence interval. It goes from a negative number, negative 6.823, blah, 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 to a positive number. What matters here is that this interval includes 0, right? If the lower bound is, or if the lower limit is in the negative, and if the upper limit is in the positive, the 0 is in between these two. So if a confidence interval includes 0, that tells us that there is no significant difference here. So let's go ahead and do this interpretation. Is there statistically significant evidence for a difference in the mean height? Your conclusion should be one of the following sentences. There was the other one, but I took it out. I'll go ahead and just get rid of this sentence. There isn't statistically significant evidence for a difference in the mean height between UK and USA since the null difference of 0 is in the 95% confidence interval. So maybe, who knows, maybe you are lucky and get a confidence interval that is completely positive. What that means is there is a difference, and who is taller? UK is taller, or UK students are taller. If your confidence interval came out to be completely negative, both the lower bound and the upper bound came out to be negative, what does that mean? That means we did small number minus big number. If your confidence interval is completely negative, that means the students in the USA have higher height, okay, or they're taller. Okay, but in mine, I guess it's nice to go ahead and write the confidence interval using this interval or the parenthesis. I'll do parenthesis negative 6.83 centimeters to 3.23 centimeters. That is my confidence interval. I'll just go ahead and include it even though the table does have it listed. Okay, but that is enough. I think for this video, this one was about 10 minutes or 11 minutes long. I will come back and do number 3, 4, yeah, I'll just do 3 and 4 in my other video.